Have you ever picked up an unknown lens and wondered if it's a plus or a minus lens, or even wondered if there's a cylinder in that lens, or wondered what prescription is in the lens? At the end of this video, you should be able to understand what hand neutralization means, how to identify a plus lens, how to identify a minus lens, and even how to neutralize the lens using the trial lenses in your trial lens box. So you understand how to approach also lenses with astigmatic power. So this is very, very important. It's a skill you must master in optometric practice because sometimes you will not have access to the lensmeter. So if you want to quickly estimate the power of an unknown lens, the hand neutralization is what you should do. So what is hand neutralization? Hand neutralization is a manual method of determining the approximate power of an unknown lens by observing the movements of an object through the lens using trial lenses to cancel the movement that you see. So in simple terms, you're asking, when I move this lens, does the image move with the lens or does the image move against the lens? Then you now use another trial lens of the opposite power to neutralize the movement which you will be seeing. Then the point where there is no movement at all is called the neutral point. So you're going to keep neutralizing until you get to that neutral point. So what would you need for this? When you want to perform hand neutralization, you need the following. You need a lens, you need a target such as a cross, a line, or even a window frame. You need, of course, a good lighting for your observation. The target should be clear and preferably should be some distance away from you. And a cross target is actually most preferred because it helps you to observe movement in both the vertical and the horizontal meridians for the times that you have to deal with cylindrical lenses. Let's talk about the basic principle of lens movement. The most important rule in hand neutralization is this: a plus lens makes the image move against the direction of the lens movement. A minus lens moves with the direction of the lens movement. Let me say that again because this is very, very important. Plus lens equals against movement. Minus lens equals with movement. For example, if you move the lens to the right and the image appears to move to the left, that is an against movement. So this suggests that you are dealing with a plus lens. But if you move the lens to the right and the image in question also appears to move to the right, that means you are dealing with a minus lens. So let's start with a plus lens. I'm holding this lens in front of a target. So you watch what happens when I move the lens from side to side. I'm going to do that practical somewhere else and then I'll embed it onto this video so you can understand. You will notice that the image appears to move in the opposite direction. When I move the lens to the right, the image appears to move to the left. So this movement of against tells you we're actually dealing with a plus lens. Now, let's neutralize this plus lens. So once you know that the unknown lens is a plus lens, you neutralize it by adding minus lenses to cancel the movement of the plus lens. All right. So when you want to do this, I will have to get a minus lens and then put it together. I keep, increasing changing the power of the minus lens gradually until there's no other movement seen. And this is the point of neutrality. For example, if the movement stops when I place like a minus lens over the plus lens, that means what I have here is plus 2 because why? A plus 2 lens has been neutralized by a minus 2 lens. So in neutralizing the lens, you use the opposite lens to do that, okay? So now let us neutralize a minus lens. Like you already know how the movement goes. I'm holding this lens. If I move it to the right, the image appears to move to the right as well. If I move it to the left, the image also appears to move to the lens to the left as well. So how do I neutralize this? I get my plus lenses from my trial lens box, which is the opposite lens, of course. So I don't know, let's assume that I don't know the power of this lens. So I just pick lenses at random and then I keep increasing the power. As long as I keep noticing the weak movement, I keep increasing the power. So if there's a weak movement, I'm going to add a plus lens until that point where there's no other movement. For instance, if I neutralize this with maybe a plus 3 lens, that means my prescription is minus 3, okay, because we're using the opposite lens to cancel the movement of what I'm holding. I hope that is clear. So let's do a practical example with your spherical plus lens. I want to assume that you have your trial lens box near you. So pick up an unknown lens, just pretend you don't know the prescription. Alright, so pick it up, move it from side to side. If the image moves against the lens movement, that means you're holding a plus lens. Then you now try to neutralize. So you can try with different minus lenses until there is no other movement. Let's assume that you finally neutralized with, if you're neutralizing a plus lens and you finally neutralize with a minus 4 lens, that means your lens is a plus 4 lens. Let us do a practical with our minus lenses. So pick up a minus lens from your trial lens box. You move it from side to side, you determine the movement. Of course, you would see a weak movement. Then you pick up some plus lenses from your trial lens box and you keep moving until there is no other movement. Okay, when that point of no, when you get to that point of no movement, that means you have gotten your prescription. So if you are neutralizing your minus lens and then you neutralize with a plus 4, that means your lens is a minus 4 lens. Let's talk about the common mistakes students make when they're neutralizing lenses. Mistake 1, moving the lens too fast. If you move the lens more slowly, you're able to understand the direction of the movement clearly. Mistake 2, holding the lens too far from your eye. So you need to keep the lens reasonably close to your eye and then you maintain a steady head position. Mistake 3, using a poor target. So you need to use a like a cross line or a straight line or even a window frame, or you can use a bold letter. Mistake 4, confusing lens movement with the image movement. Alright, so just recall the movements that we have already talked about in this video. Now, mistake 5, forgetting that neutralizing lens is usually done with the opposite lenses. So if you have a plus lens and you're neutralizing with a plus lens, of course you're not going to get to the point of neutrality. All right, so always neutralize with the opposite lens. Mistake 6, ignoring the cylinder movements in the lens. So if there's a cylinder in your lens, you're not going to neutralize with a spherical lens. So I'm going to make another video on neutralizing cylindrical lenses. So let's do a quick summary of all we have been talking about, right? So if the movement moves with the direction, that means a minus lens. If the movement is opposite, that means it's a plus lens. So you now neutralize with the opposite lens. An easy way to remember what lens to neutralize with is the opposite. So if it's a with movement, you think of a plus lens. So with plus, against movement, use a minus lens. So against minus. So remember this, with plus, against minus. So if this video helped you to understand hand neutralization, please like the video, subscribe to the channel, and share this video with your fellow optometry students. See you in my next clinical series.